Hi, I'm Caleb Pogemeyer, the squad lead and development lead here for this project, and I'm joined here with Matthew Schlater, a developer for this project, and this is our CLAAS Omaha Bolted Joint Witness Mark Senior Design Showcase presentation.
Alrighty, so CLAAS Omaha, they are a company in the name, Omaha. Not based out of Omaha specifically, but they have a big factory that specifically produces these award-winning Lexion combine harvesters. That's what they build in the Omaha facility. They are a global leader in agricultural machinery manufacturing, and they have facilities all around the world where they're able to manufacture these devices. This is who was able to sponsor our project today and give us, their project for the whole year.
So going into a little bit about our sponsors for this year, we have Matt Cook, who is the Vice President of Manufacturing. And then we also have Chase Goddard, who has been who has shown up in Lincoln every single week and is giving us a bunch of feedback and other stuff about our project, and just overall just helping us, giving us a sense of direction of where we need to go with this project.
And this is our faculty, staff, and coach that we had assigned to us this year. These are two of them from UNL and one of them outside industry coach. So our project manager, Bill Browning, he's worked on this project before. Our tribe lead was Dr. Shui, and coach, Chris Hilton.
So to introduce the rest of the crew, we have Drew, who is studying software engineering, and he was our product manager. He did a lot of the working on the software behind the scenes and showing how to get our product to actually work. Myself, with a development manager and squad lead, my job was a lot of communication between the sponsor, the UNL faculty, and throughout the team. I am studying computer engineering. We have Matthew Schlater here. He is studying computer engineering. He did a lot of the electrical work and all the wiring and making sure everything is working together as intended, so nothing blows up on us. And then our final two members, El Haji and Boston, they are both going into mechanical engineering. And they did a lot of looking into the parts and making sure everything was compatible, and did a lot of the calculations within the system to make sure that the PSIs and other things were all in the right spot.
Alrighty, so coming into this year, it was the third year of this project where CLAAS had this problem where technicians, they would go through and torque each bolt and then afterwards go back and mark it with a pen. As you can see in this photo, this is what those manual markings looked like. It fully relied on a technician, and it was really just missing an automatic aspect to it that would really speed the process up and also just reduce any human error. Get rid of that human error, I should say. And since it's automatically spraying right after a bolt is torqued, that really speeds up the process, essentially doubles it or halves the time it would take.
So with this problem, it gave us the opportunity to innovate and create a solution for this problem. So our goal was to design an automated and portable system to create a reliable and visible witness mark automatically. This would reduce the time and human error in the assembly verification process. And it will also just support CLAAS in enhancing quality assurance and workplace efficiency.
Alrighty, so a lot of work was done this year to improve the solution from last year to this year. So we wanted to make this a fully portable add-on device, separate from any external wiring connections or air pressure connections. So as we can see, we made this portable add-on device that fits on the torque device. It's able to detect torque event using the accelerometer to measure vibrations, and Hall effect sensor to measure RPMs of the torque device. And once it detects the torque, it is able to spray the nozzle, and after each spray, it's able to prime the system with the pump. So a couple of improvements we made it a whole lot smaller and compact, able to fit on top of the device there. We made a huge jump in the torque detection success by adding in that second sensor. We were able to reduce the mechanical complexity with the electric nozzle. One of the big problems that they had in the previous years was solenoid leakage, and also just the solenoid breaking in general. So getting rid of that whole part really reduced the complexity there. We also reduced the footprint of the computer board that was inside. They had a bigger computer board, and we were able to condense it down to just a smaller Arduino Nano that still did all of the things we needed it to. And we also just improved the pressure creation system with a pump and reservoir, which we used a syringe instead of creating a pressurized system there.
So going into a little bit of the values and the highlights. So what we did is we designed and built a real-time torque detection system to automate the bolt marking process to remove all the manual errors. We improved the reliability by using 2 sensors instead of 1, which was the accelerometer and the Hall effect sensor to detect those torque events. And then we optimized the paint priming time with the pump that Matthew discussed, and to achieve reliable witness marks with components that are all compatible with the paint that we decided. And then we designed a scalable and modular system that can support future upgrades based on knowledge gained and with what we did this year, with what worked and what did not work this year and previous years.
Well, thanks everyone for coming, and thank you once again to CLAAS for sponsoring.